Alright, so we're now going to go through and do some constructions for our angle side angle theorem. So go ahead and pause the video here. You're going to try for a couple minutes to use a compass and a straight edge to copy the two angles and the side in the steps that you see in front of you. So go ahead and pause the video and take about 4 minutes to try this on your own. Alright, so now that you've had some time to try this, I'm going to show you how you're going to complete this construction. So again, you first want to take that segment AB that you were given, and you want to go ahead and put another point A prime, since you're copying that over here, and extend your compass so that you can determine the length of AB and copy that length over to the side. Okay, so you've just determined point B, which is going to be over here, or B prime in this case, and you're then going to use a straight edge to connect those 2 points. Okay, so there's your segment AB. Now you're going to copy one of the angles onto A prime, and we're going to copy this angle here onto A prime. Okay, and we're going to copy this angle here onto B prime. So it says first use a compass and straight edge to copy that angle. So the first thing that you're going to need to copy the angle is just an arc that goes through both sides of that angle. You're then going to bring that distance over to A prime, and you are going to copy that distance over onto A prime. You're then going to use your compass to measure the length of that arc, or the distance between the two sides of the angle, which you're going to use the arc to do. So if I line that up, that's my distance between the two, and I'm going to bring that over to my other segment that I copied and put that arc on the angle, and that now is my side, or my angle that I've copied. So again, you're going to use your straight edge to at least connect A prime through that point. You're going to probably need it to be a little longer, so we're just going to extend it up. Now I'm going to copy angle B. So again, I'm going to need an arc that goes through angle B. So I'm going to take the arc that goes through angle B, and I'm going to copy it over to my other side of my segment AB. Draw your arc. Now you're going to come over and measure that arc. Just going to make my compass a little bit shorter here so it makes it easier. And I'm going to measure how wide that arc is for angle B using my compass. Okay, so that's about how long it is. I'm now going to bring that length over to angle B and line it up over here and copy that arc for angle B. So now you have copied that angle. You're going to use a straight edge to extend through B prime and the point you just created, and you now have your triangle. If you compare your triangle with the person next to you, what do you notice when you compare those? You should notice that they are congruent triangles. Okay, and does the order in which you draw the angles matter? The answer is no. It does not matter. Okay, and the reason that it doesn't matter is because no matter which way you draw them, you notice that you are going to get congruent triangles. One just may be a reflection of the other. So you may just need to do a reflection of your triangles, but you should be able to see that you are getting two triangles that are congruent. So going on to our next activity, for activity 2, you're going to create a triangle so that both of the angles are 65 degrees. So for this one, you will need a protractor, so you're going to have to go ahead and get your protractor out. And you are going to measure out two angles that are both 65 degrees. So angle ZYX should be 65 degrees, as well as angle ZXY. So both of your angles from this triangle. So what kind of triangle are we creating? If you said isosceles, you are correct, because an isosceles triangle has two angles that are congruent. Okay? So if I line up my protractor here, I'm going to start at 0 and find 65, which is going to be about right here. Okay? So if I start here, from here all the way around to 65, I'm going to stop, and that's going to be my new side. So between X and then just the side of that, the edge of that angle from my protractor, do the same thing on the other side for angle Y. So I'm going to start at 0 and I'm going to trace around until I get to, so I'm going to start at 0 and trace around until I get to 65, which is going to be about right here. So from 0 to 65. And again, you're going to want to then use your straight edge to connect Y and then through that angle. So again, when I do that, notice I didn't quite extend that other side long enough. So I'm going to go over here to this side and I'm going to extend it a little bit further out. And notice I also need to extend my other side a little bit further out, so you should be using your straight edge to do this, just to extend it out a little bit more. And you should be able to see that you now have an isosceles triangle, and this point right here is point Z. Also, you would know that those two sides are congruent because they're opposite of the two angles that are also congruent. All right. What did you notice about the measure of angle YZX? So what would my missing angle YZX be? So if this is 65 degrees and this is 65 degrees, we know that in a triangle that the angles add up to, good, 180. So if I do 65 degrees plus 65 degrees plus the measure of angle YZX, they would all total up to 180 degrees. So therefore I would know that angle YZX, the measure of angle YZX, is now equal to 110 degrees. Sorry, nope, not 110 degrees, my bad. That your angle would equal, let's see, 50 degrees. Okay? What did you notice when you compared triangles with your group? And you should have seen that the triangles are congruent. And again, this is another reason that we can say, just by knowing an angle, the two angles and their included side. So when I say that, I'm saying two angles. This is angle 1, and this is angle 2. And the included side, this would be the included side between the two angles. I can say that they are, in fact, congruent triangles if I have two triangles that have that criteria. So again, your angle side angle, if I'm going to go ahead and pause the video here and give you a chance to try and draw this information that you see on the board. So go ahead and pause, take about 3 or 4 minutes, and try and determine the missing information in your diagram. Alright, so your diagram should look something like this. So I have triangle ABC and DEF. If I have the two angles B and E that are congruent and the two angles C and F that are congruent, then I know, and the included side B, C, and E, F are congruent, then I know that the triangles themselves are congruent. So I could then write my triangle congruent statement and say that triangle ABC is congruent to triangle DEF. Okay? Alright, so activity 3, you are just going to go ahead and try and describe a rigid motion that maps one triangle to meet the other triangle for angle side angle. And then finally, how can rigid motions help us determine if CDP is congruent to NMT? What could we do first? How could we bring the congruent corresponding sides together? What final rigid transformation should we perform? And how do you know that angle MTN maps to angle DPC? So take a couple minutes and pause the video and see if you can answer those with your group, and then we'll come back with the answers. Okay, so a reflection over the line that I drew in would be able to map one triangle to the other. So my congruent statement for this would look like triangle CDP is congruent to triangle NMT. So then again, for your next set of questions, all right, and here are your answers. So rotations, reflections, and translations are rigid transformations and therefore congruent. If we reflect the image and match up the corresponding parts from the reflection, then we know that the angles map to each other because they are corresponding parts.